Hi all, this is Krish. I am a supply chain analytics consultant and have developed my own company on supply chain analytics. I hope you're audible to me. So I'm just waiting for some few members to join. So meanwhile, if you have joined, please text your name. Yeah, I think we are having some people who are joining along with us. So we have two members. Now let's begin this. So guys, we are actually coming up with a algorithm, and this algorithm is a machine learning algorithm, which is called cluster analysis. It's called cluster analysis, and this is a machine learning algorithm. And this is used in many in many areas of business domain. And one of the business domain we are talking all about is supply chain right now. So in supply chain, this has a very important applications. So let me show you what is that important application. And also, I would like to share that we will be doing a case study also. So please be with us till the end of the session because it will be very informative because we are going to do a case study also on this cluster analysis, and we'll see what is application of this, where we can apply this particular case study. So I hope you are able to hear me, and I hope you are able to see my screen. So let's see. Cluster analysis. So cluster analysis, if you see the word cluster, making groups, right? Making groups. So we will see the application of this making groups in a last mile delivery use case. If you look at the supply chain, what supply chain is, suppose we have an OEM. OEM distributes their products to distributors. And they will be having a range of distributors, not from one area, but from pan India, from the total global. They have the distributors located globally, or maybe in pan India. And these distributors will be supplying to the retailers. And there will be n number of retailers they will supply. Now the distributors are supplying to retailers, and retailers are further going to supply to the end consumers. Right? There will be end consumers. So this group is distributor, and this group is retailer, and this group is end consumers. So, of course, the cluster analysis has application in between OEM and distributor. It has an application between distributor to retailer. It also has application between retailer to end consumers. So these are the different sections. If we break this entire supply chain into different groups or different sections, the first section is the OEM to distributor, distributor to retailer, retailer to end consumer. So there are different groups out there, right? So these groups, in all those groups, we have a scope of applying the cluster analysis. But we will take the most complex. The most complex group is between retailer, between retailer and the end consumers. That's the most complex group. So this is retailer. Let's take one of the retailer, not from all the retailers. So because we are seeing the application of the distribution of goods from one retailer to multiple end consumers. So the same concept of cluster analysis can be applied with other retailers also. So there is no difference between only thing the difference with the application of algorithm, but the case is almost same. So I'll take this is retailer number two, and he has customers all across the city. He has customers all across the city. Now the point is how many delivery boys we should employ, or how many if we do not have if we don't go if we do not go with delivery boys, and we choose to go with the number of vehicles, how many vehicles we have, how many two wheelers we have, right? That also the another way we can choose to go with. Either you choose to go with number of delivery boys, or you choose to go with number of vehicles or two wheelers, right? Because most of the deliveries, like if you look at Swiggy or Big Basket or Toffers, right? All these companies, they're making deliveries with delivery boys having the two wheelers. Some or some in some business model, the delivery boys will carry their own vehicles. In some business model, the partner or the company will have their own resources in terms of the two wheelers, or they might hire a third party who has the resources with them. So there are different kind of scenarios out there, right? So we'll take this case study of where we have the number of delivery boys. Now, so based upon the number of delivery boys, we're going to create our model. Suppose I have 5 delivery boys in a shift. So if I have 5 delivery boys, so each time I'll create 5 clusters. So the number of cluster depends on the number of delivery boys. The number of cluster depends upon the number of delivery boys. If I have 5 delivery boys, I'll derive 5 clusters. For example, if I have allocated 5 delivery boys, 3 have completed the delivery, and 2 are in transit to complete the delivery. In transit can be two definitions: while they're about to complete delivery, or they're coming back after completing a delivery. So we are not saying that after completing a delivery they are about to complete it, right? Two are available. So now for the next set of delivery, we have 2 delivery boys available, right? So initially when we started, we had an opening balance of 5 delivery boys. Then as we move forward, then what we saw is the 3 delivery boys are still to complete the delivery, and 2 delivery boys have done the deliveries and are available. So the closing balance now is 2, and opening balance is for the next set is 2, 2 delivery boys. So here we are treating our delivery boy as an inventory. How many were available in the beginning? How many are in transit? How many are in return transit? How many are available in the warehouse? So this is what we're going to use. So now we have 2 delivery boys and we get 2 clusters. So number of clusters, every time will change depending upon the opening balance of your delivery boys. It's not like that every time you'll create 5 clusters. So this is what you have to understand: the concept of how many clusters we require. The concept of how many clusters we require. If you have 5 delivery boys, so we need 5 clusters. We have 5 delivery boys, we need 5 clusters. So what are the 5 clusters? We can mark this, we can mark this, we can mark this. I'm doing randomly. This without a mathematical logic. If you have a mathematical logic, how to create that 5 clusters? That is what we need. And that mathematical logic which you create 5 clusters should also take into account the total distance traveled to those to the points in the cluster should be minimum. The two logics are there. One logic is if you want to reduce the total transportation cost, right? So what we need is the cycle time. The cycle time of start from warehouse to return to warehouse has to be low. If this cycle time is low, if this cycle time is low, then the number of deliveries by delivery boys will go up. If the cycle time is high, the number of deliveries by delivery boys will go down because if they're taking longer time, if they're taking longer time to start and come back, then we will use them less frequently. If you're taking shorter time to start and come back, we're going to use more frequently. So this is the cost model. This is a cost model which we need to use, and to achieve this cost model, we need to use two techniques. One is cluster analysis, and second is shortest distance algorithm. Shortest distance algorithm in that cluster. So one of the algorithm which is very most famously used is traveling salesman problem. So we need to use both this algorithm. If you use both this algorithm, we will be able to achieve this cost model. The cost model is we need to have the cycle time as less as possible. And if you have the cycle time as less as possible, so number of deliveries by a delivery boy will go up. And if the number of deliveries by delivery boy goes up, we use less number of delivery boys, and we can be more responsive. We can be more responsive. We can be more flexible. We can be more consistent, right? We can be more consistent, more flexible, more our perfect order frequency will go up. There are so many advantages are there if you use this particular two algorithms. So how to derive this how to do the clusters, right? These clusters means they are the points which are closest to each other. I'm not making a cluster from here. They are far, some of the points are very far to each other. I'm not going to make a cluster from like this. They're far from each other. There's no value making clusters from locations or customer locations which are far from each other unless we have less number of delivery boys. Unless we have less number of delivery. If you have less number of delivery boys, then we may have to go with more number of locations. There's a constraint there also. If the delivery time, if we have a fixed delivery time, like if you want to deliver in 30 minutes or 40 minutes, then we cannot go with big number of or large number of locations because we have to complete the deliveries at the max within 30 minutes. So we have to take that constraint also into account. If we have a time constraint with the deliveries, 30 minutes delivery or 40 minutes delivery or 90 minutes delivery, if we have a time constraint, then we have to plan our cluster in such a way that we should not go beyond 30 minutes. That is another model. So we are not taking that model into account, a time constraint model. Right now, what we are going to do is we are going to make the clusters based upon the number of delivery boys. Of course, if you have a time constraint, you will put a time constraint also into the model. So let's look at how we will build the cluster model. And I'll take a very small case study. I'll not take a very big case study, a small case study. and I'll try to explain how the cluster is made, right? So I'm going to use a small matrix. So when you want to build a cluster in Excel or maybe in a statistical tool, you have to build a location cluster data. A location cluster is the first step. Your data model, when you're preparing your data, the first thing what we need is a location cluster. Location cluster is, suppose I have four locations. Let's say my four location is Delhi, Chennai, Patna, Hyderabad. The same thing I'll build Delhi, Chennai, Patna, Hyderabad. So what is Delhi to Delhi? We are not traveling from Delhi to Delhi, right? Our objective to travel is Delhi to a different location. So this all will be blank. So Chennai to Chennai, Patna to Patna, Hyderabad to Hyderabad. It doesn't make sense. So we are going to fathom them. All this will be fathomed, right? Now we'll put a distance between Chennai to Delhi. Let's say this is something like 1,000 kilometers. Patna to Delhi. Let's put this is 700 kilometers. Hyderabad to Patna to Chennai. Let's put Patna to Chennai something like 900 kilometers. Hyderabad to Delhi. Let's put 1500 kilometers. Hyderabad to Chennai. That is, let's say this is 900 kilometers. Hyderabad to Patna. Let's put this 1000 kilometers. So this location distance can be found by using geosatellite data. Or if you have a distance with you in your database, you can use that. So if you go Excel, you'll get a code from there. The VBA code you'll get. That VBA code you can use to build this distance matrix. The VBA code is available in Excel. So you can find the data, how to find the distance between two cities using a VBA code. Just put that into Google. You'll get a code. You have to go to VBA. You have to open F11. You click on F11. You'll open a page where you have to paste that code and give an enter. And you will be able to use that VBA code, and you can generate the distance between two cities. And you can put 30 or hundreds of cities together. But you have to build the data in this particular matrix. And if you see, I'm not putting any values over here. See, Delhi to Chennai. So this is like Chennai to Delhi. Both are same. I'm not putting any distance over here. I'm not putting Delhi to Patna. Patna to Delhi, I have the distance already here. I'm not putting anything over here. So all this will be blanks. We'll not put anything over here. Remember this. Don't put any values above this diagonal. With this data, if you look at this diagonal is there. This diagonal is where we have all fathom values, because distance between two cities makes no sense. So this is what the fathom. Now this is where the central line. Now don't put anything over this green line, the diagonal line. Put everything below the diagonal line. This is one option. Second option is don't put anything below this line. Put everything above this line. Choose one of them. Choose either the area below the diagonal line or above the diagonal line. But don't choose both of them. It's going to increase your workload, because you're doing this entire analysis in Excel. So you have to reduce your workload. If you want to reduce your workload, put data either below the diagonal line or above the diagonal line. Don't put on both sides, because the finding distance between Delhi to Chennai is equal to Chennai to Delhi, unless you define that they have different routes. If your ongoing route and return routes are different, then that's a different case. Okay, so take one of them. So this is how you build your matrix, and then we'll take this matrix and go to Excel, and from there we'll start building the model, cluster model. So let's go to Excel. So I just kept a model already ready with me, so that we minimize our time of processing this model. So what I will do, this is my four locations, and I have built the matrix just now I have mentioned here. So what I will do is now I'll find the minimum value of this, minimum value of each column. I use the formula minimum So for the column G, this is the first column, we had a minimum value of 165. From second column, we had a minimum value of 344. On third column, we had a minimum value of 307. And the fourth column, we have only one data point. So we'll get 419. And fifth column, we have nothing here. So yeah, A5, A5 here, and A4 to A4, nothing here. Yeah. So on the fifth, we have nothing over here. Okay. So this is what my minimum value. Now what I will do, I'll find the minimum of step 1. But this is my step 1, for example. This is my step 2. So what is the minimum of step 1? So I have 4 data points over here. I'll find the minimum value of them. Is 165. So the minimum value of these 4 data points is 165, which is coming from the first column of the matrix. Right? So what I will do is I'll mark this. I'll mark this the point where 165 exists. This is a point where 165 is present. Right? And this 165 is present in row number A5. Row number A5 and column number A1. So this is my first cluster. A1 and A5 is my first cluster. How did we find this first cluster? The first cluster is we took the minimum values of all the 5 columns, and from this 5 columns we found the minimum value of this. Again, we found the minimum of those 5 columns. This is 165, and 165 exists over here. And what we do, we scrap this. So this is A1 and this is A5. A1 and A5. The first cluster is A1 and A5. Now what I will do, the second step, what I will do is I'll copy this data over here. I will remove A5 from row as well as column. Right? I'll remove from here and I'll name this as A5, A1, A5. This is my cluster. The new cluster which we form, that we have to name now as A1, A5. So because we have made the cluster, so we have to remove A5 from here. We have removed A5 from here. Now we got a new matrix with cluster A1, A5 and the rest of the locations. This is the first cluster we made. Now always remember, you have to remove, when we made whenever we make clusters, we have to remove the row area, the row 1 first, like A1 and A5, right? A5 is in the row and A1 is in the column. So here A1 is in the column. So A1 is in the column and A5 is in the row. So what we will do every time, we will remove the row part A5 and A5 and keep A1 and rename A1 as A1, A5, A1, A5 and both the sections, here also, here also. The same process will follow for finding the next cluster. So what I first, before that, I'll have to find, because now the distance has to be renewed. Previously it was distance between A1 to A1, A2 to A1, A3 to A1, A4 to A1. But now the new distance is between A2 to A1, A5, A3 to A1, A5, A4 to A1, A5. So this is not, we cannot take the same distance what we have over here. So we have to get a new distance. So if you look at it here, so A2 to A1 or A2 to A5, we have to find distance between A2 to A1 and A2 to A5, and we have to choose minimum of them. to find a new distance. So this is a new model of finding a distance. So A2 to A1. A2 to A1 is how much? 287. A2 to A5 is how much? 165. 344. The shorter distance is 287. So we'll use 287 over here. So distance is 287. So already it is present, so we don't need to make any changes. Same thing we'll look for A3 to A1 and A3 to A5. So what is the distance between A3 to A1? A3 to A1 is 318 and A3 to A5 is 373. Again, we have a shorter distance over here, that is 380. So we don't have to change anything here because what we have is the shortest distance already. We don't need to make any changes. Now we'll find distance between A4 to A1 and A4 to A5. A4 to A1 and A4 to A5. So let's see this also. So A4 to A1. So A4 to A1 is 254. And A4 to A5 is 419. And the shortest of minimum of this two is 254. And we already have that. So in the current situation, with this current scenario, we had no requirements. We got no requirements to change the distances because whatever distances were placed over here, they were already the minimum distances. So that's a good thing for us. Our effort has reduced. We don't have to do anything. Now this is our new matrix. So every time after building the cluster, you have to change your matrix. Every time after building the first matrix, you have to change your matrix by taking the lowest values between that matrix to the other locations. Now what I will do, I'll follow the same steps, find the minimum of each column. So what is the minimum of these three? 254. And where is 254 located? Over here. Right? What is the new cluster now? We will fathom this. We'll fathom this. Right? So the new cluster is our A1, A5, A1, A5, and A4. So A1, A5 are closer to each other. The meaning of how we read this, A1, A5 are the closest. And then A1, A5 together is closer to A4. A1, A5 together is closer to A4. This is the meaning of this. We will not read like A1, A5 and A4 are closer to each other. A1, A5 and A4 are closer to each other. We will not read like this. A1 and A5, they are together. That's because that's the first cluster. Now A1, A5 together are closer to A4. That's the way we have to read this. Right? Now, we got a new cluster. So we'll follow the new process. Again, we'll remove. We'll remove this A4. We'll remove this A4. We are left with this cluster. Right? Now what we will do? We'll find the new distances. Again. And this time it will be between A2 to A1, A2 to A5, A3 to A1, and A3 to A5. So A2 to A1, A2 to A5, A3. Oh, sorry, I have to rename the cluster. Sorry, I forgot to name the cluster. So this will be A4, and this will be A4. The new cluster. Right? So we have to also find a distance between A1, sorry, now we'll remove this. So A2 to A1 and A5. A2 to A4. A3 to A1 and A5. And A3 to A4. Now we are going to find the distance between A2 to A1 and A5, the previous cluster. We are not going to find A2 to A1, A2 to A5, A2 to A4. Right? We have two clusters here, A1, A5, and A4. So we'll find the distance between A2 to A1 and A5, A2 to A4, A3 to A1 and A5, and A3 to A4. So if you look at the values of the previous matrix, A2 to A1, A5 is 287. And A2 to A4 is how much? I think we have removed from here. Yeah, from here. So A2 to A4, that is 348. Smallest is 287. So we'll go with 287. Similarly, A3 to A1, A3 to A1, A5. What is the distance between A3 to A1, A5, A1, A5? That is 380. And what is the distance between A3 to A4? A3 to A4 is 307. So the lowest is 307. So we'll put here 307 now. So this will remove, we'll put 307. This is the only change we're going to put on our matrix. So we'll copy this matrix. I'll hit our next cluster. This is our new cluster. Okay. So now we'll find a minimum of again. Min of this 287 and 350. Again, we find the min of these two. It is 287, and 287 is present in over here. So this is A2, right? And this is what? So we are going to remove this time A2. So this will be removed. This will be removed. We're going to be left with the new matrix. Now this is one group, and we will have A2. This is one group, and A2. And since we are left with only one data point, so last cluster we will have also get the last cluster now. A1, A5, and A4. We put under one bracket. And we'll put A2. This is another bracket. This is our cluster is complete. So if I have to draw this cluster into a dendrogram, the dendrogram is a model, is a visual model. Dendrogram is a visual technique to display the clusters. This is drawn between distance. Distance is on the y-axis and locations on the x-axis. So let's draw a dendrogram. So our locations are A1, A2, A3, A4, and A5. These are the locations. And these are distances. The first cluster which we got is between A1 and A5. If you remember the first cluster which we found, it was between A1 and A5. So what I'll do here is I'll join A1 and A5 together. And the distance was how much? 165. This is 165. So A1 and A5 is my first cluster, which I got. Now second cluster is, after A1, A5, we got a second cluster is A4, A1, A5 and A4. So I'll connect this A1 and A5 with A4. A1, A5 with A4. Now the third cluster which we got, or let's build like this. A1, A5, first cluster. Then we are going second cluster. So A1, A5 with A4. And what is distance here? 254. Distance is 254. This is 165. This is 254. What is third cluster now? It is with A2. So this model, which is a combination of A1, A5 and A4, is going to connect with A2. This is A1, A5. This is A1, A5 and A4. And this is A1, A5, A4 and A2. And distance here is what distance we got over here is 287. And the last is between 83. And this is what we got. And the distance what we got over here is 348. 307. So this is what we're going to connect with this. And this is 307. So if you assign A1, A5 to one delivery boy, this is one possibility. You can assign A1, A5 and A4 to one delivery boy. If you assign A1, A5, the total distance will be 169 kilometers, 169. If you assign A1, A5, A4, the total distance travel will be 254. If you assign A1, A5, A4 and A2 to one delivery boy, he will travel 287 kilometers. And if you assign one delivery boy to A1, A5, A4, A2 and A3, he will travel around 307 kilometers. This is all with one delivery boy assignment. Now if you go with multiple delivery boys, so A1 to A5, give one delivery boy. Then A4 to A2, second delivery boy. Or you can give A2, A4, A2, A3, second delivery boy. This is another model. Third model, A1, A5 and A4, one delivery boy. or A4, A3, A2, and A3, second delivery boy. I'm deriving these clusters based upon this structure. I'm not deriving these clusters randomly. I'm not deriving these clusters randomly. I'm deriving these clusters based upon this dendrogram. So this is a way you can actually derive your clusters and you can reduce your total traveling time from start, from a point to start, point to end, and again point to end to point to start. Because a truck or a delivery boy or a vehicle has to start from the warehouse and reach to multiple customers and reach the last customer. And for the last customer, it has to come back to the again to the center or to the hub or to the warehouse. So total traveling time we have to minimize. If we minimize total traveling time, we can use that resource multiple times. So this cluster, this is the first step of the optimization, making clusters. If you make a cluster, and that cluster will help you to optimize your delivery boys total traveling time from point to start or point of start to point of end and point of end to the point of start. So this is a very powerful tool in transport optimization, building, we are making the total delivery points or delivery locations into clusters. We have to derive the total clusters. We have to derive the total delivery locations, or we have to divide total delivery locations into clusters. Right? Total delivery locations into various kind of clusters. That is the first step of optimization. Divide the total delivery locations into clusters. Now, let's assume that we got a cluster. Let's assume that we got a cluster. So how to assume that we got a cluster? Now, how to find the shortest distance between them, among them? How to find? There are various algorithms are there. I'm going to choose the most simplest algorithm, and I'm not giving any fixed starting point here. I'll give this name as 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 delivery locations, and I'll just give a name here. 1, 2, 3. The same thing what I've done on the top. Now what I'll do is now I'll do population over here. I'll populate now. Previously I didn't populate. Okay? I'm going to populate now. So 122 to 87. 123 318. 124 254. 125 that is 165. 126 that is 449. 127 that is 295. Okay, 1283, 17, 129, copy this, transpose, special, copy this, special, transpose. Sorry guys, I'm taking this time extra because I was not actually planned for this, but I want to share this stuff with you guys. That's why I'm it's an additional which is not on the plan. Start. It won't take much time to complete this. It's a very easy algorithm. So we have read already now. So what I'll do, I'll use a formula called index. Okay, this is my array. And I'll freeze this because I'm going to repeat this formula for other cells. So this, let's say this is my row number, this is my row number, and this is my column number. I close the bracket. What is the meaning of this? The meaning of this is the distance between 1 and 2. The distance between 1 and 2 is 287. Let me put over here more. The distance between 1 and 2 is 287. 1 and 2 is 287. If I drag this formula further, the distance between 2 and 3, between 2 and 3 is 350. Like this, if I drag further, I don't need this. I don't need this one, so I'll. So this is I18 and J18. So up to this we require. I think this is what we don't want. Yeah. So this is distance between L18 and M18. Up to this we want. So if I have to travel all the nodes, how much distance I will travel? This is what 2571, and let's say this is my cluster. This is my one cluster. So within this cluster, I have to choose my points in such a way that my total distance which I travel minimizes. So for that, I'll go to data and go to solver in the Excel. This is Excel function, and I have to minimize this distance to 51. I'll choose minimum, and I have to change these values. So these are the locations which I have to change. Okay, and I want all these locations to be different. I want all these locations to be different. As well as I want all these locations to be integer. Okay, and I'll go and choose evolutionary method and click on solve. And let's see how much distance we will travel if we use this cluster. And what are those locations? Which location will come first? Which location will come last? Which location will, right now, if you look at the order, it is from 1 to 9. Let's see what is solution we'll get. In this cluster, we have got a cluster. That's the first optimization. But within that cluster, which location we should travel first? Which location should we travel last? Which location we should travel second? That is second optimization. Like in the initial we have discussed, when we do the optimization, transfer optimization, the first optimization is make the cluster. Now cluster by cluster, when you make cluster, that is not the end game. When you make the cluster, within that cluster, you have to choose the sequence of cities. And that sequence of cities, when you choose, that should minimize your total travel distance. And if you minimize the total travel distance, you minimize the total cost also. So this Clustering and this optimization, to a two-step optimization, not only help you in reducing the distance, but also helps in reducing the cost also. It's a very powerful algorithm which you can execute in Excel. You don't need to buy any software, or you don't need to use any software. You don't need to use any coding on Python or R. It's a very simple two-step process you can use in Excel, and you don't need to recreate every time. So this is what we call a solution. It's just that you can create a template and you can copy and paste the template, and you can just work on the optimization. Initially, we got a model where we had first position was 1 and the last position was 9. Now it is telling us first position is 8, means start from 8. Start from 8 and end at 4. So we got a solution now, and that solution is suggesting us start from 8, end at 4. Start at 8, go to 2, then 7, then 6, then 3, then 9, then 5, then 1, then 4. And from 4, you can go back to your original destination. This is what the solution is suggesting us. So we have done a two-step optimization, guys. The first step optimization is we have gone through the model and created the clusters. And we plotted those clusters on the dendrogram. Using cluster analysis. Then we plotted those clusters on dendrogram. Then we analyzed how many delivery boys we have. And then we allotted the clusters to delivery boys. And we created route optimization. Route optimization for each clusters. There are many methods out there. I have used a very simple model, but we don't have time to explain the detailed model. There are many models out there which we can use to build. This is one of the models. So this is a 5-step process we are using, and we're doing entirely on Excel. You can create a template, and on the template you can if you work on a template, it will not take so much of time to create the outcome. That is what you have to take into account. Don't worry if you're seeing this. This is a first time creation. When you do first time creation, it will take some time. But when you when you make the template and work on the template again, you will not require so much of time. And the time which you're investing on this particular model is going to give you a lot of benefits on the cost side, like on the transport cost side, on the utilization of your vehicles, utilization of your delivery boys. Right? If you use one delivery boy 5 times in a day, versus if you utilize the delivery boy 3 times in a day. If you use your vehicle 10 times in a day, if you use your vehicle 5 times in a day, it makes a big difference to the cost. So if you want to try, you can try this experiment in your company and see whether you're able to achieve cost optimization on your, you can also, this time you can also apply on the vehicle route optimization. We call vehicle route optimization. There you can apply, right? The same algorithm, cluster analysis plus TSP algorithm. You can combine both of them and work on the vehicle route optimization. They're going to give you a lot of benefits. In case if you have any questions, you can connect with me on my email ID. I'll share my email ID. Krish Naidu at mathanal.com. Or you can also WhatsApp me at plus +91 8977 And also, we're launching some trading programs on supply chain analytics. So, this kind of algorithms, machine learning algorithms, are part of the trading program. If you want to join trading program, which is starting from November 15th, you can connect with us on this same contact details, and we can share more details about training programs, and we can help you on that. Okay, guys, so I will take a leave. Thank you very much for participating on this live session and watching the video. If you have any queries, please do share your queries, and we will reply back to you on the platform, social media platforms. Thank you, guys. Thank you very much.